Hey everybody, this is the next troubleshooting screencast, vlogcast, whatever, all about Cisco ASA troubleshooting methodologies for the ASA platform. And again, we're using our very simplified little lab setup here. We have a 3-interface ASA 5505 firewall running version 912. Clients are on the outside interface. They're gonna. I have a server constantly trying to access the web server at 10.3.6.50 on port 80 every 5 seconds. Right now, it cannot reach that server, so something's wrong. Something's busted. We got to fix it. 3-interface firewall, outside, inside, and DMZ. But since we know that the traffic should just be coming from outside to inside, we can just focus on those interfaces, which is a key point, because if your ASA has 50 or 100 or 200 interfaces, you can't just start going through all the different interface configurations to find the problem. You've really got to narrow down on what the egress and the ingress interfaces are, and narrow down your troubleshooting efforts on those. So just like always, let's start with a packet capture apply to the outside interface. So show capture, cap out interface, outside match TCP, and we'll do any going to host 10.3.6.50 on port 80. So I made that mistake in the last video too. So we're going on the outside to our web server, and let's go ahead and apply it to the inside as well. Inside match TCP any host 10.3.6.50 EQ 80. Let's clear the captures. Clear cap/all and show cap. See they're filling up. They both have packets, meaning that it looks like traffic may be reaching the web server. Let's take a look. If I do show cap out, lots of data. Okay, it's hard just to look at this and see through the matrix to find out what's going on. So what you really want to do is focus down in on one connection. So for this, I like to just, you can't use the sequencer of the ACK numbers because the ASA is going to be randomizing those. So one thing that's going to be unique on these connections is the source port, 40699. So I will copy that, and I'll rerun that same command again and grep for just 40699. And what that does is it'll narrow down just that one connection. Okay, so that's how we can start narrowing. If I can fix why this connection's broken, I can probably figure out why the other connections aren't working as well. So just looking at this capture, first packet we see is a SYN packet because the S flag is set. I can see the sequence numbers there. And then immediately afterwards I see the ACK come through, the SYN ACK packet. I know it's a SYN ACK packet because the S flag is set and there's an ACK number. And if I look at this ACK number, it is 1 greater than the previous SYN. And then finally, there's the final ACK from the client that completes the 3-way handshake. So we have bidirectional communication between the outside client and the inside server. So that's a good sign, right? Our previous 2 troubleshooting videos, I think that wasn't working yet. But here, it looks like there's something going on, right? That's pretty good. 3-way handshake comes up, and then there's this push packet from the client, 148 bytes of data. There is an acknowledgement sent from the server, and then no data for exactly 1 second. You can see the timestamps over here. So 1 second later, it looks like the client sends a fin and tears down the connection. So connection comes up okay. Client sends a packet with some data, 148 bytes of data, and then 1 second later, everything gets torn down. That's the problem, right? That's from the outside perspective. So, and let's actually look at this packet. We can do show cap out packet, and let's take a look at packet number 13 detail. That shows us some more information, but if we say dump, it'll dump out the full packet contents, and we can see here, yeah, it's an HTTP GET. Okay, so the question is, why does the GET get sent through and then we get an acknowledgement but nothing back? So the command we were running was show cap out pipe grep 40699. Let's look at show cap in 40699. And here we see, okay, the 3-way handshake's coming up, SYN ACK, and then the next packet we see is the fin from the client, which is really strange because you know, the 3-way handshake comes up at second number 22, and then right away on the outside we saw the client send the HTTP GET, but it looks like that doesn't actually make it through the inside because we don't see that packet for a full second. Not that we don't see anything until we see the fin from the client on the outside. And then here we can see a second later a packet from the server, a push packet from the server, 591 bytes of data. something's going on. I mean, the first thing to notice is that this HTTP GET never made it through the ASA. Okay. One of the only reasons why the ASA would selectively let some packets through in a connection and then drop others is if there was some sort of inspection being applied to the traffic. So that's advanced application inspection. You see that in the service policy and the policy map configs. It's called modular policy framework, whereby you can apply inspections to traffic. So probably something like that is going on. So what we can do to look at the counters for that is to run show service policy. I'll go ahead and clear those. I'll say clear service-policy to clear out those counters, and show service-policy to view them again. So we run show service policy. There's a lot of the default inspections turned on. And then we've got some other classes here. We've got SIP class, but I'm looking to see the number of packets up that have matched these different classes, and I see that they're all 0 except for skinny class. Okay, so there's a class of traffic defined called skinny class, and it looks like my packets might be matching this. Okay, yeah, I mean, what is skinny? Skinny traffic is, you know, it's Cisco voice over IP control protocol, so there's no reason that it should be matching port 80 traffic. At least by default it's not there. Let's take a look at what the configuration looks like. Show run service policy. This will show me which policy maps applied to the outside interface. Then I can run show run policy map. Sorry, this is actually applied globally. So here we are. We've got class SIP class and class skinny class, and here we have the inspect skinny applied. So let's use the show service policy flow command to simulate a sample service policy flow and see what it would match. So show service-policy flow, and we'll say we want to do TCP, and we'll specify host 10.1.1.2.11, and the source port is going to be 1234, destination is going to be host 10.3.6.50, and the port's going to be port 80. So when you run this command, it'll look at the modular policy framework config and unwind it and tell you exactly what config it would match. And in this case, it does indeed indicate that on the global policy, in the skinny class, we're matching a specific ACL called skinny ACL, and the access list rule is permit TCP any for a specific to a specific subnet and port 2000. But note that it isn't port EQ 2000, it's port less than 2000, which is the trick, right? So what's going on is traffic is matching the service policy. This HTTP traffic is being shoved through the inspect skinny engine. Inspect skinny is saying this isn't skinny traffic, therefore I'm going to drop it because it doesn't conform to the protocol, and therefore it drops it. So to fix this, we need to fix that ACL rule. The other thing I could do is just turn off that inspection, but you know, it looks like a misconfiguration on that skinny access list, so I'll do show run access list skinny ACL, and I can see here we've got the skinny ACL defined. So let's do show run object dash group, and let's specify object group skinny. And there's our problem, right? Is the object group, the service object group is misconfigured. So I'm going to go in and change this object group from service object TCP destination less than to EQ port 2000. And after doing that, I can do a clear cap out, clear cap in, show cap, and if I look on the outside, I can see now that when this push flag gets sent through 148 bytes of data, it's immediately ACT, and it looks like this TCP connection comes up just fine. Okay, so that is the solution. We had a misconfigured skinny access list, which was shoving traffic that it shouldn't have through the inspection, and that was mangling the traffic. The resolution is to fix that misconfiguration so that the ASA treats the traffic like HTTP or normal vanilla TCP traffic, and access to the server is restored. Okay? So we use show service policy, flow command, packet captures, may have used syslogs, and we looked at the capture dump output to see the details of the packet to verify which packet specifically was the HTTP GET. All right, so we used some tools and we solved the problem. All right, until next time.